we introduce the discriminant method in certain extreme value problem, that is, try to find min, max, or range of certain functions. We know that for quadratic equations with coefficient a, b, c, the discriminant is b squared minus 4ac. If the quadratic equation have real roots, then we know that discriminant is going to be greater or equal to 0. This can be used in finding the min max of certain functions. Now, with first example here, we have this fraction of quadratics. We try to find the range of y, or the mean value of y. In this method, what we do is we're going to rewrite it, and we're going to turn this into a quadratic equation in variable x. So rewrite it, and then we're going to combine the terms. This is a quadratic equation where y becomes coefficient. Of course, the discriminant is going to be used. However, if y equal to 1, this is no longer a quadratic equation. Is it possible y equal to 1? If you plug in y equal to 1, you can calculate x equal negative 3/4, which is true. So we know that the value y could be 1. Now we consider other cases where y is not equal to 1. In that case, the equation is indeed a quadratic equation here, with coefficient y minus 1 being the leading coefficient, right? So discriminant is going to be greater or equal to 0 because x is a real number here, right? So it's a quadratic equation. We use the discriminant here, delta. That's in terms of y. That's b squared minus 4ab. Here's a b squared minus 4a and b. Okay, so this discriminant is going to be greater or equal to 0. Now from there, you combine the terms, and then terms will cancel, and then you get y is going to be greater or equal to negative 3. Now the question is this achievable? Notice that when discriminant equal to 0, the root becomes negative b over 2a, negative b over 2a. So we plug in, we're going to get x equal negative 1/2. This is indeed achievable. So we know that the answer to the original question is the mean value is negative 3. It is achieved when x equal negative 1/2. All right. So this is one example of using the discriminant method in figuring out the range or the mean of y. Let's look at another example. Here we also try to find the mean of y. However, we constrain x in this range. Okay, so we know that this is going to be positive, and here is going to be positive also. The whole thing is positive. So we observe that y must be greater than 0. All right. So again, we're going to use the same trick. We're going to rewrite it. We're going to turn that into quadratic equations here, with y be the leading factor here, leading coefficient here. So when y equal to 0, right? When y equal to 0, this is not possible because here you cannot be 0 when x is constrained in negative 1 to 1, right? So what you get is y is not equal to 0. This is indeed a quadratic equation. X is a real number. So we know that discriminant is going to be non-negative. Here, you simplify that, you're going to have this range here. Now, you can change that. Here we know that y greater than 0. So we know that y must be greater than 6 plus 4 square root of 2. Again, this is achievable because when delta equal to 0 here, and the root is going to be negative b which is 4 over 2y, negative 4 over 2y, and that is, this is a negative number, right? Square root of 2 is 1.414, so this is the whole thing is smaller than 3, so x is some negative number here, and y is achieved as a minimum value. All right, so that's the second example. Let's look at another example here. In this case, we try to find the range of y, where y is again a fraction here. X is also constrained between 0 and 1. All right, so let's do that. Let's use the same trick here. Turn that into a quadratic equation. You know, y equal to 0, which is possible when x equal to 0. When x equals 0, y is 0. Now, when y is not 0, yeah, so what will happen? This is a quadratic equation, and the whole thing should be real roots, so delta is going to be non-negative. So we're going to plug that in, and that become a quadratic inequality here. If you have two roots, y is going to be between the two roots, right? So let's solve that. That's the range of y. So we're looking for the range of y. Is this the answer? Unfortunately, the answer is no. Why? Because x is constrained in this range. So this is the incorrect answer if you put this here. Okay. As a matter of fact, we graph the function here. Indeed, y is between these two values we showed earlier. However, that is when x is unconstrained from negative infinity to infinity. We have the maximum and minimum here. But here we constrain x in this range, right? So of course, without looking at the curve, how would you figure out the range of y? Here we notice that this quadratic equation here, we look at here. Now the coefficient here, a equal to c, which means the product of two roots is going to be 2, and we're looking for x in this range. So which means this quadratic equation must have a root that is going to be one root in this range, the other root will be greater than 1. Okay, so there's only one root. You cannot have two roots both in this range because the product is going to be 2, right? So in this range, there's a root in between this. In order to have the root in between 0 and 1, what you have to do is that this function here must have negative sign for x equal to 0, x equal to 1. This is kind of fundamental theorem in calculus, right? So in order for this quadratic equation to have roots in 0 and 1, one root, right? So we must have f0 and f1 must be negative, right? So plug that in, we have this, and now for this quadratic you can solve it by y is in between 0 and 3/4. Okay, so that's the answer to the question. So here in review, we introduce this method here, but sometimes if the x range is constrained, you probably want to be careful about evaluating the y range. All right. So if without constraint, you can use the discriminant method in figuring out the range of y. All right, that's it for today. Hope you like the video. Please share and subscribe.